Hey guys, I'm going to teach you how to find the surface area of triangular prisms. By the end of this lesson, you'll be able to find the total area covering a 3D object, which is the surface area, except this time they'll have triangular bases. So go ahead and turn to the math section of your binder and get ready to take some notes. Let's start by reviewing everything we already know about 3D objects. First of all, I know a shape is three-dimensional because it has a depth. It's not a 2D flat surface. It's made up of two-dimensional shapes. So this is a rectangular prism, and this is a pretty basic 3D object because all of its faces are made up of rectangles, including its two rectangular bases. And we named the prism based off of the name of the bases. So because it's rectangular bases, it's a rectangular prism. One type of rectangular prism is a cube. A cube has square bases and faces where every edge of the cube or side has the same length, because in a square, every side length is the same. So if I was going to find the volume of this cube, I would do a times a times a, which is the same thing as a to the third power, or a cubed. And that is why we call the third power cubed. Today, we're going to be looking at triangular prisms. I want to show you this picture because a triangular prism is different from a pyramid in a few different ways. For one, everything in purple is the base. If you notice, a triangular prism has two triangle bases. I know they're the bases because they're parallel to each other. The pyramids only have one base. This is a square pyramid because it has a square base. This is a triangular pyramid because it has a triangular base. So this is a triangular prism, and that's what we're going to be looking at today. And I just wanted to point out that a triangular prism is not the same as a pyramid. So let's go ahead and jump in with a little more review. Let's take a step back and find the area of a two-dimensional figure. So this is a rectangle and this is a triangle. Using the formula for the area of a rectangle and area of a triangle, pause the video, plug in your values, and then press play when you're ready to check. I know that the formula for the area of a rectangle is base times height, or length times width. So I do 12 times 7, and I get 84 square feet. For a triangle, I know the formula is 1/2 the base times the height. The base is 12, the height is 7. The height is the distance from the very tip to the bottom. So I don't need to use the 9.2 at all. When I multiply 12 times 7, I end up with 84, and then take half of it, or divide it by 2, and that's how I get 42 square feet. So if you could sum that up in a sentence, go ahead and describe what's the difference between the area of this rectangle and this triangle with the same dimensions. Pause the video now, fill that in, and then press play when you're ready to check. So hopefully you said something like this. You want to find the area of the triangle, you multiply the base times the height and divide by 2, or multiply by half. I could basically fit two of these triangles into one of these rectangles because the area of this triangle is half of the area of this rectangle. We'll be able to apply that information to our 3D shapes later today. So see if you can figure out what the connection is between that. Let's go ahead and jump in with some triangular prisms definitions. A triangular prism is composed of 3 rectangular faces and 2 triangular bases. So in this picture here, you can see that the triangles are parallel to each other and they're not touching. That means that they are the bases that this object could sit on, even though it's not sitting on them right now. So those are the bases, and the faces are the 3 rectangles. Same for this picture, and then this is a net of what that looks like. So keeping in mind that the bases of three-dimensional objects don't touch, shade in the bases of each of these figures below. Pause the video now, do that, and then press play when you're ready to check. All right, so you should have shaded in the triangles on each of these. If you shaded the rectangles, you would have made a rectangular prism. Remember, a triangular prism is named based on the bases. So it has 2 triangular bases. So now that we've identified all these parts about triangular prisms, let's go ahead and start finding the surface area of the triangular prism. We're going to do that by using a net. Decomposing each net into different concurrent figures, we're going to find the area of each figure, and then we're going to add them up to find the surface area. So go ahead and pause the video now, see if you can do this by yourself, and then press play when you're ready to check. So I'm going to start with shape 1. Shape 1 is my rectangles. I see 3 of them, and they all have the same dimensions. They're 8.5 by 6 rectangles. Using the formula length times width, and plugging in my values 8.5 and 6, I know that each one of these has a total area of 51. And again, that's square inches. Shape 2 is going to be my triangles. I know the formula for the area of a triangle is 1/2 times the base times the height. And I'm going to look at this triangle for reference. So I'm looking for the base. The base would be that bottom part here. And it doesn't say it right here, but it does say it over here. That 6 is congruent to this 6, to this length here, because it's all on the same rectangle. So it's part of this triangle. So this has a base of 6 and a height of 5.2. So I just multiply those and then take half, or divide by 2. When you do that, you get 15.6 inches squared. I know that there are 2 triangles, each one has an area of 15.6. So go ahead and find the total surface area by adding up all of these areas, which gives you 184 and 2/10 of a square inch. If you got 66.6, you are like Billy Bob and you just added up 51 and 15.6. That's not how this works because there's 2 triangles and 3 rectangles. Surface area is the entire combined area of the 3D object, not just the 2 areas that you can see. So let's start doing a couple of practice problems. On number 4, you're finding the lateral surface area. Remember, that's the surface area of the whole figure except for the triangular bases. So you're just finding the surface area of the rectangles. On number 5, you're finding the total surface area. So go ahead and pause the video now, try both these problems, and then press play when you're ready to check. All right, so here are your answers to number 4 and 5. If you need to go over these, please pay attention, and I'm going to go over each one at a time. Otherwise, you can fast forward to the next 2 problems. So number 4 says find the lateral surface area. Like I said, that's just the area of the rectangles. I can see that the dimensions of the rectangles are 7 by 4 for these 2 on each side, and the one on the bottom. And I can see that because this is a 4, and then again, that's a 7 on the bottom. Using my formula length times width, I want to plug in my values 4 and 7 and multiply to get an area of 28 square feet for one of these rectangles area. I know there's 3 rectangles in this triangular prism, so I'm going to multiply this by 3 to get my answer, 84 square feet. Let's look at number 5. It's an example about chocolate candy and the wrapper. Anytime you see a problem about wrapping paper, it's a problem about surface area. So what you want to do is find the area of each side and then add them all up. So the front and the back of this triangular prism are 16 by 2.6 centimeters. I don't need to multiply those because that's the length times the width. That gives me the area of the rectangle. And there's 2 of them. There's a front and there's a back. So I put it times 2. Now the bottom of this triangular prism is also a rectangle, but it is a 16 by 2.2. That would make the bottom rectangle. There's only one of those, so I don't need to multiply it by anything. There's only one of those. Now I need to find the area of the triangles. There's 2 of them and they are congruent. I know the formula for area of a triangle, 1/2 times the base times the height. The base of the triangle is 2.2 centimeters. That's the red line. The height is 3 centimeters. So I'm going to plug those values into my formula. Since there's 2 of them, I'm going to multiply the whole thing by 2. When I evaluate my expressions, I end up with 83.2 plus 35.2 plus 6.6, and I end up with 125 centimeters squared. Go ahead and look at the next 2. Pause the video now and press play when you're ready to check. All right, so let's start going over number 6. If you notice, there's 3 different size rectangles. So let's look at the one frontward, this red one. This is a 6 by 4 rectangle. I see those dimensions here and here. I'm going to use my formula for area of a rectangle, which is length times width, so I'm going to multiply 6 and 4 to find the area of the red rectangle. Now let's look at the next one. I highlighted a blue rectangle. The 2 dimensions are a 5 by 6, so I'm going to write that into the formula for area of a rectangle. And then the last one is this other kind of front one, and I put it in orange here. This is a 3 by 6, and I know that because it's 3 inches wide, and I'm looking at how tall it is. That height is going to match the 6 inches height over here. They're going to be the same. So it's a 3 by 6. I'm finding the total surface area of this unique jewelry box. I'm going to find the area of the triangles as well. They are congruent triangles, which means they're the same. So I'm going to find the area of one triangle and then multiply it by 2. So this is the part that might get a little tricky for you because you have a 3, a 4, and a 5 that go with the triangle. So you need to use the formula for area of a triangle and then look for what values you need to plug in. You need to use the formula 1/2 times the base times the height. That'll give you the area of a triangle. The base and the height for this triangle are what makes the right angle. So 3 and 4. You're not worried about that 5 because that 5 doesn't make the right angle. So that's not the height, that's the slanty side. And in a right triangle, we would call 5 the hypotenuse, and you really just need the legs. So you plug those values into your formula. You can do 3 times 4 divided by 2 or times 1/2. Either one is the same thing. But since there's 2 triangles, I am going to multiply the whole thing by 2. Now here's a quick shortcut. I know that 2 times 1/2 is 1 because half of 2 is 1. I know that 2 divided by 2 is 1. So before I do this in my calculator or do this in my head, I'm just going to cross out the 2's since they cancel. And I'm just going to do 3 times 4 for the triangle. And you can think about that making sense because 2 of these right triangles would make 1 square. Now you're going to find the area of each face. Take a second and do that now if you haven't already. These are all the areas of each face, and surface area tells me I need to add them up. So I'm going to add up all the areas to get 84 square inches. We would need 84 square inches of wood to make this unique jewelry box. Number 7 should be a little bit easier because what they've already done for you is taken this triangular prism and unfolded it into a net. So take a second if you haven't already and find the surface area of this triangular prism, and then press play when you're ready to check. All right, so the hardest part for this is finding out which of these sides of the rectangles is what. So if you think about folding it back up, this 3 would fold with this length right here. So that would be 3. The 4 obviously would stay where it is. This is a 4 and this is a 4. And then that 5 would fold up onto this. This is 5 and this is 5 because they would fold up onto each other. So let's go ahead and find the area of the rectangles first. This is a 3 by 9, so this is a 27 centimeter squared area rectangle. This is a 4 by 9, so this is 36. And I'm just going to write the number in, make it easier on myself. And then the top one is a 5 by 9, so that's a 45. And then for the triangles, you need to figure out which one's your base and which one's your height. It's what makes the right angle. Don't worry about the hypotenuse or the slanty side. Just do 3 times 4, which is 12, and then divided by 2, or times a half. So each one of these is worth 6. When you're finding the total surface area, you're just going to add up the areas of all the sides. So when you add them all up, you get 120 centimeters squared. All right, guys, that's it. If you made it to the end of this video, please put in the comments, if you had to design a wrapping for your candy bar, what would the name of your brand be? Mine would be Mr. C's Number Nuggets, and it would be like a chocolate bar, but inside would be filled with little caramel clusters, but every caramel nugget would be a number. Today we learned all about surface area of triangular prisms, so now you should be able to find the total area covering a 3D object with triangular bases. Now you should go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye!